Hello, today we're going to be breaking down factoring, just very basic, simple factoring. And here we have 5 main points I'm going to start with. First one, we got greatest common factors, simple trinomials, general trinomials, difference of squares, and grouping. I will explain it briefly and then do an example for each. So first, let's start with greatest common factors. This is very commonly used. Essentially, we're just dividing out the largest term in an expression. So, let's start with 3x plus 15. Example number 1. We can't divide both sides by 15. We can't do that. Because you see largest, you look at 15, you say, oh. But no. Just because it says largest does not mean you can divide by 15. Because 3 divided by 15 does not work. 3 is common out of both 15 and 3. Because we can do 3 goes into 15. 3 times 5. So we take a 3 out of both. So we lead our answer off with a 3. 3 divided by 3 is just 1, so that cancels out. We're left with x. 15 divided by 3 is 5. This is our answer. We'll do one second example. You can try this by yourself quickly, so be a little bit more advanced. Plus 21xy squared. So give that a try, and if it looks a little bit more intimidating, but it's not bad. So we see 7 goes into 21 here. 7, 14, 21. So we know that's a common factor. So we know we can start our answer with 7. We see an x here. We see an x here. Even though there's x squared, that means we have essentially x times x, and there's only one x here. So what's common about this is there's an x in both expressions. So we can take that in. Same with y. Even though y squared, we still have a y in both expressions. So we can take that in. So now we just divide each of these by 7xy. 7 divided by 7 is just 1, cancels out. X squared divided by x, that's essentially, we have 2 x's and we're taking away 1 x. So I like to just cross that, and we're just left with x, so that comes down here. And y, just cross out, and that's nothing. So we move on. 21 divided by 7 is positive 3. X divided by x, sorry, this is an x. Nothing. So we have 2 y's, and we're taking away another y. Just right here. Essentially that cancels out. So we're just left with y. And that right there. That's your final answer. And if you want to check your work, if your teacher asks you to check your work, always sub back in. You might see it called FOIL, but this is just expanding an expression. You just expand it, and then you will get back to your answer up here, or your first expression. That's how you know you did it right. Okay, let's move on to simple trinomials. This takes the form of x squared plus bx plus c. B is going to be, b and c are going to be changing. The x squared will always be there for simple trinomials. But here we're trying to find a value that adds to this b value and multiplies to a and c. So multiply to a and c and add to b. Okay. So let's try an example of x squared plus 2x minus 8. Let's try that. So let's start. We have our a and our c values. This is just 1 essentially, 1x. And our c value, which is -8, so a and c is -8. Their b values too. So 2 numbers that multiply to -8 and add to 2 is -4, 2. No, 4 and -2. Yeah, 4 and -2. That's just mental math. That'll be habit. in a little bit. Okay, so those are our answers for simple trinomials. Those are important. So that's just x, and we take our two answers and just plug them in like that, and that is your answer. If your teacher asks for roots, solutions, zeros, what they're looking for is this x value, essentially. What we do is we set the equation to 0, and we say, what do we need to do to this x minus 2 to make it equal 0? So x minus 2 is equal to 0. X needs to be 2, right? So one of our solutions is 2. Same with this side, x needs to be negative 4. So that's what they're looking for when they say zeros or solutions. They're looking for something like this. So we have 2, negative 4, so it might look like this. Alright, let's move on to, let's try difference of squares next. This is going to take the form of a squared minus b squared equal to a plus b, a minus b. And where a and b are the variables, obviously. So let's begin with an example. Let's try x squared minus 4. Just a simple one to start. We'll do another one. So for difference of squares, essentially we are square rooting. Okay? We're square rooting values. So we square root x squared, and we square root 4. We do not include, don't include this negative sign. Because if we do root negative 4, that is not, there's no solution to that. Because when we do root 4, we know it's 2, but it's not just 2, it's plus or minus 2. Because negative 4, you can't root negative 4, because negative 2 times negative 2 makes positive, right? So, I'll erase some of this. Back to our question of x squared minus 4. We root this, we root this. And now, square root of x squared, just x, because x times x is x squared. Square root of 4 is 2. And that is actually our a and b values. So now we have a plus b. Now we just need to do a minus b. That is your answer for that question. And then same thing, if you were to FOIL this out, you would end up getting the original expression. Okay, let's try a little bit of a different type of question. Let's try 4x squared minus 16. Let's try that. So, same thing. Root, and we root. So square root of 4, 2. Square root of x squared, which is x. Right? That's your a value. Square root of 16 is just positive and negative 4. Make sure we leave this out. Leave it at the negative. So that's our b. So now we do 2x minus 4, which is our b value. And then that is your answer. Again, FOIL everything out, and you come back to your original expression. Okay, let's move on to general trinomials next. Or you know what, let's do grouping. Let's try grouping. This takes the form of A, B, C, and D. Right? We have 4 values, and we essentially want to split them into 2 groups, A and B and C and D. The way to check if we can factor by grouping in that expression is if we can match the ratio. So if B over A is equal to the same ratio of D over C, we know that we can factor by grouping in a problem. So for example, let's say I have 3 over 1. So this would be 3, this would be 1. And then I had 6 over 2. So this is 6 and this is 2. Let's say we had that as our leading coefficients. The ratio is 3 to 3. 3 divided by 1 is 3, 6 divided by 2 is 3. We know we can factor by grouping for this question. So let's start with an example. Let's try x cubed, sorry. Let's do x cubed plus 3x squared plus 2x plus 6. So, again, we're going to split it in half. Make sure that this is on the right side. I see a lot of people leave out this symbol right here, and that costs you. And now what we do is we just do greatest common factors. So we know this. So greatest common factor of these two terms is x squared. Divide that out. Divide out x squared and x squared. So you're just left with x plus 3. On this side, greatest common factor is 2. So we divide out 2. Lead out with positive 2. Go x plus 3. Notice how these two terms are the same. That means we can combine them. And then we combine these two. So we do x squared plus 2. X plus 3. Perfect. That's your final answer. Some people might say, hey, is this the difference of squares? Can we factor this more? No. That is a common misconception. You cannot do that. I'll explain briefly why. If I were to root this and say, oh, well, you can just square root, it's 2, right? It takes the form a minus b, a plus b. So there has to be a minus somewhere in here. And once I FOIL all this out, I'm going to end up getting x squared minus 4, which is not the same as that. X squared plus 4. So we cannot do difference of squares there. Okay. Last one. General trinomials. Takes the form of ax squared plus bx plus c, where this leading coefficient a is the term that is different. So let's do an example quick. Let's try 3 to 2x squared plus 11x plus 12. Okay, so the same thing. We do a and c, or a and c values. 2 times 12 is 24, and 11. So as to add to 11 and multiply to 24. Mental math, it's 8 and 3, both positive. But instead of those being our final answers, we drop this leading coefficient. We drop this leading term, sorry. And then we think to ourselves, what's easier to work with a 2? 8 or 3? Since 2 is a factor of 8, we're going to say it is much easier to work with than the 3. And essentially, we're just splitting up this x to make it easier to work with. And now, you'll notice, we're back to grouping. It's essentially just splitting up this middle term to make it easier for ourselves. So we solve this by grouping. And I will do it quick. So we go 2x, x plus 4. And this is just 3 plus 3, x plus 4. And then 2x plus 3, x plus 4. That is your final answer. So I hope this gave you guys a little intro to factoring. The reason factoring is so important is as you progress through high school and to your 4U classes and your harder, more difficult classes into university, this stuff needs to become habit. And because the numbers are only going to get harder to deal with, you're going to deal with roots and different expressions that are going to be really tough to deal with if you do not know how to factor. You need to know how to factor very well. So thank you for watching this quick video, and I hope I was a help.